Hello students, today we will see the second PU electronics model paper. In this the problem section, which is part D, first main. There are 6 questions, out of which you need to answer 3. Each carries 5 marks, so totally 15 marks. This section contains 15 marks. So we'll see all those 6 problems one by one. Before we go into the actual problems, if you are a new visitor to my channel, new viewer to my channel, please do subscribe my channel. After watching the video, hit the like button, press the bell notification icon so that you will receive all my new videos. Also, share this video with your friends so that they can also take the help from this video. The first problem, it is 36th problem in part D, first main. Calculate the voltage gain. Voltage gain is AV. Input impedance, this is Zin. There are 2 input impedances, Zin and Zin base. Here it is Zin asked. Output impedance ZO in the circuit given below. Also, the other details are beta and RE dash formula is given. From this circuit, I can write given. First, from the question, let us take beta, that is current gain is 100. Then RE dash, this is transistor emitter resistor, this is 26 millivolt by IE. The moment we see 26 millivolt, we should understand it is silicon transistor. Hence, its VBE, even though it is not given, you can take it as 0.7 volt. Sometimes they take it as 0.68 volt also. So I have taken it as 0.7 volt. In the textbook, PU prescribed textbook, it is given 0.68. Anyone you can take. Little bit difference will be there in the value. Then what are the other details? We can take it from the circuit. R1 is given as 90 kilo ohm. R2 is given as 22 kilo ohm. RC, that is collector resistor, is given as 5 kilo ohm. RE, emitter resistor, is 1 kilo ohm. This emitter resistor is DC resistor, wherein this emitter transistor resistor is AC resistor. Along with this, we need VCC, which is equal to plus 12 volt. So, we have taken all the given details. With this, we will proceed. Before we calculate voltage gain, we need to calculate basic things. That is, we need to calculate voltage across base and emitter, that is voltage drop across R2. I will call it as VB because it will be easy to denote. The base voltage, since emitter is grounded, I can call it as base voltage. This is equal to, I will get the formula as VCC into R2 by R1 plus R2. This is using voltage divider rule. Then if I substitute these values, all the values are given here. Seeing this, VCC is 12 volt, R2 is 22 kilo ohm, then R1 and R2 both are in kilo ohm. So what I will do is, I will just put the numbers in the bracket and 1 unit outside. So kilo ohm get cancels. If you do this calculation, 12 into 22 by 90 plus 22, you are getting 2.35 volt. We can check this in this calculator. 90 plus 22 is 112. So we'll just directly do it. 12 into 22 equals divided by 112. So 2.357, it continues. You can take only 2 decimal numbers. So it is 2.35 volt. After this, I need to calculate IE, because to calculate RE dash I need IE. So IE is equal to VB minus VBE by RE. VB, we calculated it as 2.35 volt. VBE is 0.7 volt as I said here, divided by RE is 1 kilo ohm. It is voltage by ohm, so the unit will be ampere. Since it is kilo ohm, I can write it as milliampere. And if you calculate this, 2.35 minus 0.7 is 1.65. Since divided by 1, it will remain as it is. IE is equal to 1.65 milliamps. Now we need to calculate RE dash. RE dash is given as 26 millivolt by IE. This is 26 millivolt by 1.65 milliamps. You see, milli get cancelled. Volt by amp is ohm, and 26 divided by 1.65, I will get 15.75 ohm. RE dash is equal to 15.75 ohm. These are the basic thing that we need to calculate first before we actually go into the other calculation. These things also carries marks. Now we'll move on to the next part, that is voltage gain, input impedance and output impedance. These three we will calculate. So voltage gain, AV is the voltage gain. This is and is given by the formula minus RC parallel RL by RE dash. RL is load resistance. This is absent here, it is not given. Hence I can rewrite this formula as A is approximately equal to minus RC by RE dash. So why that minus we will see, I will explain it later. We will just calculate the answer first. Minus RC is 5 kilo ohm divided by RE dash is 15.75 ohm. Ohm and ohm get cancels. This can be written as minus 5000 by 15.75. So it is AV. So AV will be equal to minus 318.47. Since it is gain, it is unitless. The negative sign indicates there is a phase shift of 180 degree between input and output signal. That is, if the input signal is like this, I will get the output amplified signal in this direction. That is, whenever I apply positive half cycle, I will get negative half cycle. Whenever I apply negative half cycle, I will get positive half cycle. So to calculate voltage gain, I need to do all these calculation. So just for voltage gain, the allotted marks will be 3, this will be 1, this will be 1. 3 plus 2, that is 5 mark. So let us now see the input impedance and output impedance. So input impedance, the formula is 1 by Zin is equal to 1 by R1 plus 1 by R2 plus 1 by beta RE dash. This is because if you remember the transistor RE model, you have 3 resistors at the input which are connected in parallel. This is beta RE dash, this is R2, this is R1. Then I am having a current IC, then at the output I am having RC and RL. So then we are taking here the output. That is why this forms the input. Of course there is a ground here. This is emitter, this is base, this is collector. RE model of the amplifier and transistor. So these three are connected in parallel. Hence it is 1 by Zn is equal to 1 by R1 plus 1 by R2 plus 1 by beta RE dash. If suppose it is Zin base, then it is simply beta Re dash. Now let us substitute the values. This will be how much beta Re dash? 100 into beta was 15.75. So it is 1575, and keep this in kilo ohm range. The reason is R1 and R2 both are in kilo, so keep this also in kilo range. That is 1 by 90 plus 1 by 22 plus 1 by 1.575. Whole thing is divided by K. Now taking LCM is a tedious task. What I do is I will calculate this through calculator. First I will take 1 by 90. If I calculate 1 by 90, 0.011 I am getting. Then 1 by 22, 0.045 I am getting. Then 1 by 1.575 I am getting 0.636. This whole thing will be divided by kilo. Then this is 1 by Zin. This will be equal to 0.692 by kilo. Zin will be equal to K by 0.692. If I calculate this, I will get 1.44 kilo ohm. Since unit for Zin is ohm, I am rewriting that unit. So input impedance is 1.44 kilo ohm. Then the last one asked is output impedance. This is Z0, which is equal to RC parallel RL. If RL is absent, not given, then it is approximately equal to RC. Here you need not have to calculate anything. Directly you can write off output impedance Z0 is equal to 5 kilo ohm. This is the answer for this problem. We'll go to the next problem. The gain of an amplifier is 100 and its output resistance is 2.5 kilo ohm. After this, a negative feedback is applied. That means this gain is a gain without feedback. After a negative feedback is applied, the output impedance will reduce to 500 ohm. Now I need to calculate what is the value of beta. Again, before the feedback, if the bandwidth is 200 kilohertz, what is the new bandwidth? So we'll write down the given things. Gain before the feedback is A, that is 100. Then output impedance, that is ZO, is equal to 2.5 kilo ohm. After the feedback it reduces to 500 ohm, means ZOF after the feedback. Bandwidth is given, that is 200 kilohertz. I need to calculate beta and then bandwidth after the feedback. These are the two things I need to calculate. By formula, ZOF is equal to ZO divided by 1 plus A beta. If I rearrange, I will get 1 plus A beta is equal to ZO by ZOF. This will come here and this will go here. Let us substitute and calculate. ZO is 2.5 kilo ohm, means 2500. This is equal to 2500 ohm divided by 500. So 1 plus A beta will be equal to 5, because if you take these two, 25 by 5, it is 5. So what will be A beta? 5 minus 1, that is 4. Beta is equal to 4 by A, that is 4 by 100. Beta is equal to 0.04 or 4%. This is the value of beta. Now the second one is bandwidth with feedback. This is equal to bandwidth into 1 plus A beta. that is 200 kilohertz into, you have already taken here 1 plus A beta. You can simply substitute 5. This one here. So 2 5s are 10, 2 zeros, 1000 kilohertz, or in other words, I can write 1 megahertz. This is the bandwidth with feedback. You are noticing here output impedance before the feedback is more and it reduces after the feedback, whereas bandwidth before the feedback is less, after the feedback it increases. This is because the bandwidth graph without feedback will be like this, the frequency response. With feedback it will be like this. So if you calculate the bandwidth with feedback, this will be from here to here, whereas bandwidth without feedback, suppose if I calculate, this is up to here. This is bandwidth. This is bandwidth with feedback. This is without feedback. This is with feedback. This is frequency. This is gain. So this is for the second problem. This is not required. This is for the understanding I gave. So those who forget the formula, you can just think any parameter, that is input impedance, voltage gain, output impedance, bandwidth, any of these things either will increase or decrease by the parameter 1 plus A beta. So input impedance is increases because it is voltage series. So it will be multiplied by 1 plus A beta. Wherein gain reduces, so it is 1 by 1 plus A beta. Output impedance reduces, so if I have to write ZOF, it is 1 by 1 plus A beta. Wherein bandwidth with feedback it increases, so into 1 plus A beta. So this is just a general information for you to understand, because this feedback problem is the easiest problem to attend and to score maximum marks in this. Okay, let us see the next problem. Find the output voltage for the op-amp circuit shown below. Now, before you go into the actual equation, let us see, let me mark this as VO1, that is the first output, and let me write what are these two circuits are. This is op-amp subtractor. You could notice the values are different. This circuit is inverting amplifier. So first one, let us see VO1. It is a subtractor minus RF by R1 into V1. What we do, we take the output of an inverting amplifier plus output of a non-inverting amplifier, that is 1 plus RF by R1. Then we will have voltage divider. What I am taking is, here this is R1, this is R2, this is R3, this is RF. Voltage divider rule, because the input applied here is through the resistor R3, I will write R3 by R2 plus R3 into the voltage applied is this. Okay, let us substitute. Minus RF is 5 kilo ohm, R1 is 1 kilo ohm into 1 volt plus 1 plus 5 kilo ohm by 1 kilo ohm into R3 is 5 kilo ohm, R2 is 1 kilo ohm, R3 is 5 kilo ohm into 3 volt. Now you could notice minus kilo get cancels, 5 by 1 into 1 is minus 5. Now plus, what happens here? 5k by 1k is 5, 5 plus 1 is 6, no need to take LCM, into, this is again 5k by 6k, so that it becomes 5 by 6 into 3 volt. 6 get cancels I'll get minus 5 plus 15. Minus 5 volt plus 15 volt. That is how much? 10 volt. VO1 is 10 volt. Now second one is inverting amplifier output is minus RF by R1 into VO1 now. In this case RF is 12K, R1 is 6K. This is the second part of the circuit. The values of the circuit components also will change. We need to take care of that. VO1 will form as the input to the second circuit. So this is equal to minus 12 kilo ohm by 6 kilo ohm, and VO1 I got it as 10 volt. So this will become to, that is minus 20 volt. VO is equal to minus 20 volt. Actually speaking, we need to connect plus VCC and minus VEE. This maximum will be plus or minus 15 volt. Minus 15 and plus 15. So it cannot go beyond that. Actually VO should be less than 15 volt. But since the problem values are given like this, we need to just calculate according to the values and keep. Next sum, a transistor Colpitts oscillator has L is equal to 4 millihenry. L in the sense inductor. So write down L is equal to 4 millihenry. Milli is 4 into 10 raised to minus 3. Then C1 is equal to 10 nanofarad. 10 into 10 raised to minus 9 farad. C2 is equal to 10 nanofarad. 10 into 10 raised to minus 9 farad. I need to calculate the frequency. Formula says F is equal to 1 by 2 pi root L CS. CS is given as C1 C2 by C1 plus C2. I can calculate that CS is equal to 10 into 10 by 10 plus 10 into nanofarad, because 2 nanofarads divided by 1 nanofarad, I'll get 1 nanofarad. Instead of getting confused, I can do that. This is 100 by 20 nanofarad, that is 5 nanofarad. Or if C1 is equal to C2 is equal to C is equal to 10 nanofarad, then CS will be equal to C by 2. That is 10 by 2 nanofarad, that is 5 nanofarad. Whichever you want, you can use that formula. Now substitute that in the formula. F is equal to 1 by 2 pi root 4 into 10 raised to minus 3 into 5 into 10 raised to minus 9. Now group these two. What will I get? That is 1 by 2 pi root 4 5 20 into 10 raised to minus 12. 9 plus 3 minus 12. You know A root A square is equal to A. How? A square to the power of half. Similarly, 10 to the power of minus 12 root, if I take 10 to the power of minus 12 into to the power of half is 10 to the power of minus 6. F is equal to 1 by 2 pi into 10 raised to minus 6. I am taking this outside the root into root 20. I can even rewrite this as 10 raised to 6 by 2 pi root 20, so that calculation becomes easier. If I do this calculation, I will get 35.16 kilohertz. I'll show this calculation right now. Let us see first 20 root. I got this. This should be multiplied by 2. This should be multiplied by 3.14, that is pi. I got 28.085. 3 decimal up to this it is enough. So 1 divided by 28.085. I got this, and you know in the numerator it is 10 raised to 6. 3 I'll keep it as kilo, and into 10 raised to 3 will be there, that is 1000. If I multiply that by 1000, I'll get 35.606. Okay, so it is 35.606. I'll change this 35.60 kilohertz. This is the next problem. So only here you need to take care is how to do the calculation. That is very, very important. Otherwise your answer will go wrong. The next sum is from modulation and demodulation. 36th sum is from amplifiers. 37th sum is from feedback amplifiers. 38th sum is from op-amp. 39th is from oscillators. 40th is from modulation and demodulation. Now a 10 kilowatt carrier wave is amplitude modulated at 80% depth of modulation by a sinusoidal modulating signal. Calculate the total power and sideband power of amplitude modulated wave. So what are the given things? You could see carrier wave and the unit is watt. So the first one is carrier power, that is 10 kilowatt. Depth of modulation is modulation index, it is 80%, or I can write it as 0.8. I need to calculate total power and sideband power. For the safer side, I can calculate PLSB and PUSB also. Now by formula, total power is given by PC into 1 plus MA square by 2. This is the first one. So this is equal to 10 kilowatt into 1 plus 0.8 square by 2. This is equal to 10 kilowatt into 1 plus 0.64 by 2. Can do this. This is 0.64 by 2 is 0.32 plus 1 is 1.32 into 10, that is 13.2 kilowatt. This is total power. Second one is sideband power. The relation between total power and sideband power is PT is equal to PC plus PSB. So the sideband power is given as PT minus PC. This is the easiest formula. That is 13.2 kilowatt minus 10 kilowatt. It is 3.2 kilowatt. This is sideband. Power of each sideband. You know there are two sidebands, upper sideband and lower sideband. In amplitude modulation, upper sideband and lower sideband carry the same power. So PLSB is equal to PUSB, which is half of the power of total sideband. Both carry half of the power. So if the power at the sideband is 3.2 kilowatt, it is 3.2 by 2, that is each sideband carries 1.6 kilowatt. That is power of lower sideband or power of upper sideband. Then the last sum is from digital electronics, that is K-map. How to draw the K-map? First we should know. Since it is 4 variable, write 4 into 4 boxes, and the parameters are, suppose if it is A, B, C, D, we need to write A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D, C, D bar. Let us write the minterms inside. 0, 1, 2, 3. I am writing opposite. See 0, 1, 3, 2 instead of that 0, 1 I wrote the last one and then here. Similarly 4, 5. This I am writing it as 6 and 7. I will come to the last row. 8, 9, 10, 11. Then this is 12, 13, 14, 15. However it is convenient, you can write. Now I will enter the values. Sigma m means whatever the numbers it is written here, all those things should be filled in by 1. So 1, this box should have high value. 3, 1, 5, 1, 7, 1, 13 and 15. I need to enter this as don't care, that is X. 0, 12 and 14. Rest of the things should be filled in by 0. This is how we need to enter K-map. Okay, let us group in this. This is one quad and this is another quad. Also, we can group this as one quad. There is no chance of making octets, and pair is not required when there is a chance of making quads. For this quad, if I write quad 1, I should see it is between these two rows and these two columns. I should write which is not changing, that is A bar and D. So this quad will be A bar and D. This is second quad. Again, for this I need to see between these two because it is second and third column. Not changing one is B. But this is common D. So quad 2 I will get BD. And this quad is not required. I can write it as redundant group. Why it is redundant group? Because all ones are already grouped with quad 1 and quad 2. So it is not necessary to quad this again. Now the answer is Y is equal to A bar D plus BD. I need to realize this using only NAND gates. So Y is equal to A bar D plus BD. This plus should be converted into that is AND gate. Hence I need to put 2 bars so that it will be, if I demorganize this, I'll get A bar D the whole bar, plus will become dot, OR gate will change to AND gate. This becomes BD the whole bar and whole bar. Now you can see in this expression that all are AND or NAND expressions, so that we can easily realize the simplified expression using only NAND gates. So now let me see A. I have to write A bar using only NAND gate, that is like this. This is A bar. Then D. If I take these two, it becomes A bar D the whole bar. I got the first one. Then the second one is B and D connected to another NAND gate. So this is BD the whole bar. Now I need to connect these two to the last NAND gate, which gives me expression Y, that is A bar D the whole bar dot BD the whole bar and the whole complement. That is, if I redo this, double complement, AND gate will change to OR gate, again double complement. Double complement cancels, so I will get A bar D plus BD. This is the expression that I had to realize through only using NAND gates. Thank you for watching this video. If you like this video, please do subscribe my channel. Hit the like button, share and comment. Thank you once again.